All right, we're going to look kind of back at unit circle. The basic trig functions, sine, cosine, and tangent, you learned about in geometry. From there in trig, you kind of proceeded to learn about the reciprocal trig functions of cosecant, secant, and cosine. Notice that cosecant is the reciprocal of sine. Cosine is the reciprocal of secant. Try not to do the ones that are the same, like just because this starts with C doesn't mean the reciprocal of C, it's actually the opposite there. And that secant is the reciprocal cosine. And then tangent, cotangent are easy to remember because they sound the same and they are reciprocals of each other. Some other trig properties to remember that we looked at. We got our little joke here, that's the sine of gerene over the cosine of gerene equals tangerine, because sine over cosine is equal to the tangent function. So that is a common trig identity that you should know. Some other ones that come up a bunch and that you should know, that the one we just talked about, sine over cosine is tangent. That would also mean then that because cotangent is the reciprocal of tangent, cotangent would be sine over cosine, or sorry, cosine over sine for cotangent. All right, so then that brings us to unit circle. So if we're looking at the unit circle here, and we pick some point on the outside of that, some things happen. One, if it's a unit circle, the reason it's called unit circle is that the radius of the circle is 1 unit. And so anywhere where we draw a line from the middle to the outside has a length of 1. So right here, if I pick this point, this line from the center, this radius would also be 1. And that would always be true of any point from the center to the outside. Well, also created by this ends up being a right triangle. And we know some things about right triangles here from trig. So if we were to call this point the point xy, what happens then is that this would be our x value, this would be our y value, and using some trig here, we can come up with some equivalencies. So one of the functions we have is cosine. Cosine uses adjacent side to our angle over hypotenuse. Well, in this case, if we did cosine of our angle, that would equal our adjacent side x over our hypotenuse of 1. Well, we don't need to write something over 1, so that would just be x. So our x value is always the cosine of our angle when doing unit circle. Similar, if we do our opposite over a hypotenuse, that's sine. And so sine in this case would be opposite of is y over our hypotenuse of 1, which y over 1 is just equal to y. So your y value when you're doing unit circle is always equal to the sine value. So those are some things you need to remember. Your x value is always cosine of the angle, y value is always sine. And you can, the easy way to remember that, if you're looking at this way, that we know that's x, that's also the adjacent side of the right triangle, so that means it's going to be cosine. Up and down y, that's going to be opposite, so that would be sine. All right, the other thing you can do with right triangles besides trig is good old Pythagorean theorem. So if we were to do this on this one, we know that x squared plus y squared would equal our hypotenuse squared, or 1 squared, or just 1. And so if we know x and y are equal to cosine and sine, that gives us this Pythagorean theorem equivalent with trig in there. So cosine squared plus sine squared is equal to 1. So that is another trig identity that you should know from last year. That one is not a hard one to remember. We did have some harder ones to remember that involve like double angles and half angles. Those do not need to be memorized, but the ones talked about here you should have a common knowledge of.